So this is one example. You have pump to water your plant, right? Your flower, to water your flower. Okay, if you have this one, I think your flower will die immediately because the pipe diameter is 20 cm. That you water the flower, gone. It's like tsunami, small tsunami to the plant. Right? Everything is given, Q is given. Okay, this is, you are considered lucky if it is given there, right? Q. Because most of the time it is not given, so you need to calculate between this and that, and then you got Q, then you calculate between this and that. Right? The pump intake is located at 1.8 meter above the water surface level. What is the NPSH, right? And everything is given. So it's pretty straightforward. You have that. Okay. P1 is PATM. P2 is the one that you need to calculate. Okay, so P1 is not zero. Remember, P1 never zero. P1 is atmospheric pressure. Why never put zero? Because if I put zero, you will get problem later on when we have this calculation. Right. Suddenly you put zero, then all the calculation will be wrong. Okay, so that one is the atmospheric pressure. So if you do that, major losses is neglected in this particular cases. This two is neglected. No soft power, of course, because it is before the pump. Okay, you may argue with me, so there is a pump, why don't you put that pump? Come on, this one is at the inlet of the pump, just before the pump. There is no other pump there. Okay, so this one 0, this one 0, you put there. And the phi2, okay, phi2, in this case, is calculated from that. Q over A, so you got your phi2. Then you have this one is your P1, P1 over gamma, P2 over gamma, right? P2 over gamma is there. This one is your phi2 over 2G, Z, losses. Yeah? So you calculate that, you look at your P2 over gamma, then given the condition, you can calculate the PV, vapor pressure. So you can calculate your NPSH. The NPSH is 8.12 meter. Okay. Now, given this, if your required NPSH is 4 meter, you are safe. But if your pump having NPSH of 12 meter, this pump cannot be used. Cavitation will occur. Right? Because cavitation will occur. Is that clear? Thank you. Actually, the best teacher is your peers. That's the best teacher. And the best way to learn is to teach. So if you want to learn now, teach. Okay, that is one type of question that can be given to you. Another type of question is, what is the maximum height you can put before the cavitation occurs? Just like your siphonning case last time in your fluid mechanic one, but this one is in case of cavitation for the pump. So what is the maximum height you can have before the cavitation starts to occur? Basically, the concept is still the same. You are just having those things, right? So everything remains the same until you get this one. This is the required NPSH. NPSH cannot less than this. This is the minimum you have. So if you want to get the maximum H, this is the minimum required NPSH that you need to have. Okay? So if you set that one, you will know that the maximum elevation of the pump from the water surface is 2.3 meter. Okay? Remember, this one is from the water surface. Okay, so this one is talking about this. Okay, because last time what happened is, I don't know, I mean, I'm just too creative that time, so I put this pipe like that. Instead of, usually I will put like that, right? Then I put that. This time I put it longer like this. Then, some student calculate the height from here, which I love. So it doesn't really matter. It matters only here. But of course, if you put the longer pipe, the losses will be there. But this one is not coming for the height. This one will come to your HL. It's not going into the maximum height like that, but it goes to your HL. Because you have the length of the pipe there. Doesn't matter, it's from the surface. This thing, this head, now I'm talking about this. This head max is from the surface of the reservoir, not from the entrance of the pipe. Because when you set one, the one is not at the entrance of the pipe, it is at the surface.